You're on.
All right. We are assembling the final product. We have this box to save work on carpentry, which I would rather not do. If I see a set of speakers cheap and it looks like the cabinets are well designed, I usually will take them and modify them rather than build my own. I got these at the Sound Source for 60 bucks a piece, and the woofer that's in them, the woofer that came out of them is useful as a guitar amp speaker. So I pulled that, and the cabinet is well built. It's made out of particle board. And most important is the dimensions of it. Nowadays, speakers always have walls that are splayed. Like that, you'll see them in the store. It's actually, there's no evidence whatsoever that a rectangular cabinet is inferior sonically to those trapezoidal things. What is true is that it's cheaper to make a good speaker out of the trapezoidal, because the lack of parallel surfaces does give you an advantage as far as standing waves within the box. A rectangular cabinet, you have to just take more time to get rid of those standing waves. But if you are willing to take that time, a rectangular cabinet works just as well as any other. The ratio of these sides is familiar, because the Audio Engineering Society did a lot of research in the 1950s and found a basic shape, dimensions, a ratio of height to width to depth that gives you the most accurate response that a rectangular shape can make. Now, it is true that you can get more accurate speakers by going with odd shapes, a sphere being the most accurate. You can figure out how to build a spherical cabinet that's really nice and solid, go for it. So the drivers that I've chosen for this are Electro Voice EVM12s. There's a reason these actually are a guitar amp speaker, and they operate in what's called the second breakup mode. And what happens is that at some frequency, as the frequency goes up, they operate as a piston like this. But at some point, the piston, the cone starts to vibrate like this, and that's what Thiel and Small referred to as a breakup. And that actually creates a boost in the output, in the amplitude of the output, and it also alters the phase, and it kind of creates a driver within a driver. It's a mid-range driver within a woofer, and if you know how to harness it, you can do a lot of good things with it. If you don't, it just creates this horrible resonance that makes everything sound really horny and honky. But if you use it properly, you can do a lot of cool things. And what we're going to do with it in this speaker is we're going to create a PA system that has a little bit of a bite to it, so that the musician can hear himself over the instruments. Accuracy is not always what we're going for. So we're using this speaker, this woofer, and so we're going to drop that in there, and then the high-end driver, we're using this. It's basically just a PV RX14, which is a surprisingly good driver for the money. It actually sounds like a $300 driver, but it costs like 89 bucks. And the horn is a very interesting shape. I've never used one before, but I saw them. I bought them used, cheap, and I knew right. You could tell right away that these are pretty high tech, and that they're well thought out. You know, if you do my very high tech method of measuring the response of a horn is to simply listen to them like this. And you know, as horns go, I mean, I can tell that these need to be crossed over. They got wicked resonance right around, I'd say about 300 hertz. But a horn like this would never be used that low. These are going to be crossed over well above 3 kilohertz. And I don't hear anything up there. So I think these are going to be nice, accurate horn. Whatever inaccuracies exist, we deal with in the crossover stage. So we are going to drop these drivers in. We use not Sonics, we use this stuff to line the speakers with. On the inside, it works a lot better than fiberglass. That's an understatement. And so these will be finished in a little bit, and then we will voice them and trim up the crossovers a little bit, and I hope the client enjoys them. All right.
Hey, stop it.